episode 7 of the AI Basecamp podcast. And today, our topic, in quite prosaic words, is smaller, faster, cheaper, lighter. Are small language models the future of widespread AI adoption? And as always, I'm joined by the head of AI at K2, Aleksander Obuchowski. Before we get into it, Alex, maybe a couple of quick words from your end.
Yeah, so today we're going to talk about small language models, and it's a pretty interesting topic because so far we have seen the advancement of large language models, right? So we see that GPT-4 is much larger than GPT-3, and there are those larger and larger models. But what is interesting actually is that for the most applications, you don't need the fully large language models. And there are a lot of concrete examples that we're going to talk about that show where the small language model actually shine and when you can use them.
And even the uh, bright face of the LLM revolution, if you want to call it that, Sam Altman, CEO of OpenAI, recently stated that he more strongly feels that the future of AI and LLMs in particular, or language models in particular, is not to go bigger and bigger and bigger and bigger in parameter size, but rather optimize other levers and also explore the advantages of maybe even letting many smaller models working together. The Apple Worldwide Developer Conference that took place a couple of weeks ago again pushed into this direction, local deployability, smaller models, so that today we really want to dedicate to shedding light on that and how that can benefit you and your business to leverage value from AI to stay true to our mission. We want to talk at first about a definition. What are small language models? Briefly, but just so that we all have the same baseline and understanding here. Then we're going to become a bit technical for not too long, but we want to give some depth on them, architecture, design principles, and so forth. We will move thirdly to the advantages of SLMs over large language models, because there's a lot more than just being more energy efficient and faster for certain things. We will talk about concrete use cases, fourthly, and applications of SLMs where they beat out LLMs and can be highly useful. Then the limitations and challenges can't be forgotten as well, and we'll round it off with looking into the future, trends that are already emerging and directions that we see happening with SLMs. So that hopefully by the end of today's episode, you know a lot more about what SLMs, small language models, are, what you can already use them for, what you can soon use them for, and where the limitations lie. But Alex, now to start, over to you. Quick definition. What are SLMs?
Okay, so with SLMs, as with many AI topics, there is no clear definition, right? What's when the model becomes small and when the model becomes large. The typical definition that we use is the small language model is something that you can run locally on your device on a customer level hardware, not enterprise level hardware. So you don't need a data center to run this model. And just to show you a perspective, when we are talking about model sizes, we usually talk about hundreds of millions of parameters. And with the especially state-of-the-art models like GPT-4, well, we aren't sure, but we suspect even trillions of parameters. Now, this kind of models you definitely won't be able to run locally. You need like a cluster of GPUs. And then when you come to the smaller models, such as 70 million parameters for the newest Llama 3 open source model, it is something that you could technically run in your, let's say, not on your laptop, but on your cluster, but like a cluster that costs a couple thousands of dozens of thousands of dollars. So achievable for a company, mid-sized company, let's say. And then we go into the really small models by this definition that are like 8 billion parameters, and even some are smaller, like 3, 4, 5. Those are the models that with some clever optimization tricks that we're gonna talk in a bit, that you can run even on your average laptop with your average GPU or even on CPU. So I would say like a small language model is something that's less than 8 billion parameters, right? So thousand times smaller than GPT-4.
And
And
maybe just to collect everybody here, parameters as in weights and biases in my neural net. So in the end, just an Excel table. Yeah.
yeah, exactly. Each parameter can be, each weight is one parameter, and you can think of the weight as a knob that you can tweak. So it's transforms the input. So an 8 billion parameters model has 8 million parameters model has 8 million of those tiny knobs that you can select.
Like it, like it. Precise summary of what they are. And then obviously, before we move into the technical aspects, maybe just to briefly reiterate, more parameters in the past years usually meant the model is able to capture more complexity and therefore higher performance. But at the same time, you need not just more computing power, but also raw time, more time to train them. And of course, when we start to talk about trillions of parameters, like the cutting edge models right now, GPT-4 and Claude models, Sonnet 3.5, and then even the big ones, uh, they exceed a trillion parameters. It starts to become a real memory heavy
Yeah.
application there as well.
So why do we even see those large language models, and why do we go in the trillion parameters? Wait, I don't want to go a lot of the race here, but there is essentially my favorite essay in artificial intelligence, and it's called The Beetle Lesson, and it's by Richard Sutton, and it tells you that what we observe from 70 years of dealing with AI research, that the models that leverage computational power in the end always win with models that leverage some clear optimization tricks or some expert knowledge and stuff like that. So we, with bigger models, we will always win in terms of computing power in the long term, like with the accuracy and stuff like that. But we obviously also can't build like the infinitely large language models, because if you have too large model and too little data, you get to what is called overfitting. So the model is can adapt in any way it can because of those knobs that it can tweak, and it adapts to the training data and not generalize on the data that it hasn't seen, and it's called overfitting. And if you don't have enough data with large language model, you can easily overfit them. So there are a lot of challenges with creating large language models, right? Basically the data, the computing power and stuff like that. So that's why we see this trend, because in the end they always win, but they might not be right for your specific use case. Like something that is for everyone, for everything, doesn't have to be right for you. Like this 11 in one shampoos, right? They are good at everything, but not maybe for your specific hairstyle.
Right,
And
right.
moving to technical aspects, right? So how do we create a small language model? Well, there are basically two ways. So first way is you can train the models from scratch to be small language model, and you can just design the model that it has 8 billion parameters and just train it on the respective data. But what's actually more popular is that you start from the larger model, such as 70 billion parameters, and then you use techniques that make the model smaller. One of those techniques is called distillation, which is like the analogy to distilling the knowledge. You have a teacher model and a smaller model, and the smaller model learns to mimic the larger model, and it can be as accurate on this specific task as the large model, but can have very very few parameters. And obviously it can't replicate all of the knowledge of the larger model, but on this specific like language, this specific domain, this specific task, it can do so. There are also like techniques like quantization, when you reduce the number of parameters in the model because you go with lower precision. So as standards, you have 16, even in some cases 32-bit precision, and then you go to 8-bit, 2 bits, even 1-bit precision in some cases. And of course, there is a trade-off. Those models are less accurate, but you are able to run them even on CPU. And also you have techniques like low rank adaptation, LoRa, that you're able to fine tune large language model by just running transformation from the general model to the specific model, not the weights themselves are frozen, so you don't learn the weights from scratch. You just need the transformation from general to the smaller weights, and also you don't need as much for computing power for training such models. Uh, and to give maybe a few examples of the smaller LLMs that we currently have, right? So we have a Llama 3 8 billion parameter model, very good, very multilingual. It can speak in German, Polish, also very good, which is not always the case for open source models. Uh, we have from Phi 3 from Microsoft. We have this 7 billion parameters model. From what I tested, it is not so good at multilingual. But it's quite good on English. We have Gemini Nano from Google that you are able to run even on in browser, essentially. And there's also the Apple's version of the smaller language model with 3 billion parameters. And there are, of course, those are like the most popular ones, but there are many, many more specific that people train themselves for their specific use cases.
But yeah, it's like notably all big players by now have launched one or usually a family of models in this space. Because, and that maybe carries us nicely over from technical aspects to the advantages. Why is there so much buzz around it? And why do all the big players invest in it? Why does Sam Altman say the future isn't larger and larger and larger, but rather on different levels? The obvious first one is, and we've touched upon this, because the computational requirements are lower. I don't need massive GPU clusters. I can run it on standard CPUs. If it's small enough, I can even run it on my mobile device. That I also consume less energy. It's a lot easier to, and it only enables local deployment, which was not possible or is not possible with LLMs. You will always have to run them in some cloud. But then also, when you think about use cases like voice bots, or we all have our Google Home or Alexa around, when you want to power these, what you care a lot about is speed of response, processing time. And if I can cut out the uh, route or detour, one might say, into the cloud, processing there and then back onto device, I can improve massively on latency in certain
And this is
scenarios.
maybe to jump in a little bit. This is
Sure.
actually what Apple will do with their new release of the new iOS version. They want to process your queries locally with Siri, and if the Siri decides it's too advanced question for it to be answered locally, it can prompt you that it wants to use ChatGPT with by the API. But it's your choice, right? Your data isn't automatically sent to the cloud. It tries to process it locally, and if it knows it can't, it's your choice whether you want to use more advanced model in the cloud or not, which is, I think, quite cool.
Yeah, it's super cool. It's very promising, and it also has, I would say, at least two additional benefits. One is for the company, and one is for the user. The company benefit is that okay, if I move some of the processing burden locally, I won't have to pay for it. Very simple, obvious, but piling up a therefore important argument. And the other is privacy of data. So especially when we talk about, and I think we're going to go into examples here later, when we talk about data that is sensitive for whatever reason, you would rather not have this data, be it your voice recording or a text query or an image, leave your device, but instead you would like to keep it there, process it there, and benefit from all the power that modern generative models can deliver without it ever having to leave your device. So the privacy benefit for certain applications are massive and therefore like make these SLMs super attractive.
Yeah, I think like healthcare is the obvious example because you can't send patients' data to OpenAI servers or to some cloud. You have to, by law, like I mean, you can have deals with certain companies that process them, but it's super complicated, and it would be best if the data wouldn't leave the premises. So like using LLMs to process electronic health records is a big no-no right now. You can't do it. And if the local open source LLMs rise up to the standards where you can deploy them locally and they're super accurate and they're able to process those kinds of information, like the applications are huge. Because I'm not only talking about the fancy stuff like diagnostics and computer aided diagnostics and helping make decisions, but also stuff like processing the documentation itself. For example, some statistical analysis on the raw text, like parameterizing, transcribing conversation between patient and doctor, and automatically filling in like healthcare forms. This takes a very large chunk of doctor's time nowadays to do with the documentation, do with the administrative work. And if we are able to run small LLMs on each device, we could just do it automatically, and then doctors wouldn't need to care about that, right? So obviously, like, I think healthcare is gonna be the next big thing for small language models.
Like the example a lot, and you already carried us over into the fourth point of today, the use cases and applications. Uh, if we maybe want to add a few others here, okay, we already mentioned voice assistants where latency plays a big role, healthcare applications where privacy and sensitive data plays a big role, but also to an extent, of course, embedded systems, smart home devices, automotive systems, all of these can benefit from less energy consumption, so therefore lower costs and lower latency that these SLMs promise, provided, of course, that the respective use case is not too complex for current state of the art SLMs. Because we've talked about the advantages a lot, we're going to come to the limitations, but the complexity of the task, the SLM needs to be up for the challenge. That is of course, something to keep in mind.
Yeah, and with IoT devices, like obviously you can even run it on the Raspberry Pi, some stripped up version of Llama 3. I recently ran it on Steam Deck, right? So also not very powerful hardware, but I was able to do it, and I averaged like 12 tokens per second in the generation, so definitely usable. And I think like stuff like this, like home assistants, right now all of them have plugins to use ChatGPT, but I can very much see a scenario when you have local home assistant IoT device that is connected to all of your sensors, all of your other IoT devices, and it's gonna be huge because it's gonna solve a lot of privacy reasons as we talked about, right? So many people don't want to have smart assistant to constantly record and send this data to Amazon. But if we are able to do this locally, I think much more people will adopt it. And you were talking about specific tasks that those models can solve. Like as we said at the beginning, there are not one fit all, right? There are usually like dedicated to specific language or dedicated to specific domains such as healthcare, legal, banking. And I think it's very interesting direction that we go into, because essentially what happened with the rise of models like ChatGPT is that we AI researchers were very scared for a second, because we're like, what is left for us to do? Like, this model can do every NLP, natural language processing task, so there is no need for custom models. And then there was huge spike of prompt engineering, right? Prompt engineering jobs, prompt engineering courses. Everybody thought how to, and people were writing like those 2-page instructions to do some one specific task very accurately. And right now, I think we are in this very cool phase when we realize like this is not a way to go, that you need to spend 1 week to design the perfect prompt for the general models. You could just, if you have the data, like input and output pairs, you can just train the local model, smaller model to do this. And you don't need any prompt engineering. It is cheaper, it is faster, it's local. You can have complete ownership over that. So I think we are sort of like having a renaissance of custom models that stopped a little bit. And to name a specific use cases, stuff like classification, right? So for example, sentiment analysis, triage of user queries, uh, maybe even stuff like chatbots and voice bots, when you have to route customers to specific things. Maybe it appears it's not better to have the control on the side of the model, but take some control. Stuff like information extraction, right? We, for example, in our case, we try to to create a prototype of some app that was able to recognize names and surnames from text using ChatGPT. But there was some trick that it has to be real person, not fictional person, and assign them roles and stuff like that. And you think it is a very simple use case for LLMs, but we have to work very hard on the prompt to actually make it reliable. And instead, we could just train a named entity recognition model. It's super simple. So I think that people are now realizing that one fit for all is not the best, and each of those cases can be solved by having custom models that are not that heavy, that are easy to train, and that can run locally.
Like it, and you did touch this important point that also nicely ties back to the beginning of uh, the number of parameters or the size of the model only being one of the levers in its optimization. Another one, and probably increasingly important, is rather than focusing on larger, you can use the specific one. And why is it specific? Why is it so specific? Like working especially well for this use case. One big factor in there is that rather than scraping the whole internet or all of Wikipedia and a lot of the other internet, which comes with other data issues and privacy legal issues we touched before, you train it on less data, a smaller model, but you make sure that this data is of super high quality. So what they did, for example, for the Pi models, the Microsoft ones, they used a lot less data than cutting edge models, but it was textbook level quality, which made it easily ingestible, similar structure, similar standards, but very dense, very proven, very factually accurate. And the results they achieved were amazing. Like with 7 billion parameters, they outperformed GPT 3.5 on most benchmarks.
Yeah, this is the trend that you can see when you actually read the technical papers of Llama 3 or of 5. You see that each of those researchers emphasize data quality. And less data but of higher quality is usually better than larger number of shitty data. And if it's really hard to control the quality of the data, right? If you have like trillions of documents, you have to spend a lot of time to make sure they're high quality to train the LLM. That's, for example, why OpenAI used New York Times, because it's a quite reputable data source with a lot of articles. So it was very good training data set for them. And that's why they wanted to use this. But if you, as we said at the beginning, if you want to go with larger models, you also need a larger numbers of training data. And there are problems to keeping the quality of this data. For example, with GPT-3, I think they had this issue that because they had some filters for the proper language, let's say, it actually underrepresented African American, like dialect or
Mm.
slang or something like that. So you don't want to do that, right? You want the model to be fair and unbiased and accept all kind of dialects and languages, but it's actually very easy to, because of the restrictions you impose, to cut out some chunk of people that you do care about, and you should also incorporate the representation in the training data set. So you either
Yeah,
cut too much
yeah.
or too little, and it's very hard to do it right in between.
Very,
And
very
that's
important point that
also,
you're touching.
maybe just one more thing, that's
Sure,
also why
sure.
synthetic datasets are so popular nowadays, because what people actually also do is they use the large language models to create synthetic high quality datasets to train the smaller language models. And it's actually at first thought quite counterintuitive, right? Because you're not generating any new knowledge, you create the data synthetically, so error propagation and stuff like that would come to your mind. But it turns out it actually kind of works, because the synthetic data can even be of higher quality and are very much easier to control than the data that you scrape from the internet. So it's also a very interesting use case of where you create the smaller language model based on synthetic data from larger language models.
It's been done with remarkable success. Yeah, should we maybe now move further? Point number 5. We said we've talked so much about the positives now. We want to cover without filter limitations and challenges. So small language models they're great in terms of don't need that much. You can deploy them quickly. Latency is low. Don't use much energy, uh, and are amazing for certain sensitive data that needs to stay on device, not even on some company-owned servers or privately run servers, but on device. But what are the limitations? What are the challenges? Why don't we use it for everything?
Okay, so few things. Obviously, it depends who you are, if it's the right thing for you. Because if you are a researcher, you have some budget, you know how to train the language models. I would encourage you to do so, to experiment. But if you are a non-technical person, you don't have R&D department in your company, you don't want to waste time and money on training your custom models, it's better to use off-the-shelf models and they have nice API. You also don't pay for hosting them, right? Because hosting them could also be quite expensive if you want to have real-time predictions and stuff like that. So it's a matter of, do you the scale as you are operating, because if you are processing a few hundred queries per month, it's probably not financially viable to train your own model, because you need to spend money on training, spend money on people, and then you will get very little usage on that. So I would say that when you handle a large volumes of data, and this data is not that complex to reason over, small LLMs are a way to go, but they're not for everything, right? So if you have very advanced use case that requires very advanced reasoning, and you don't want to spend money and research or something that can even be unsuccessful, right? Because you can train the model and it appears that this is not working properly in the end. So you waste money on research. Uh, so yeah, I think like we should focus on stuff like volume, like budget for this, and the local aspect, right? Because for some use cases, it doesn't matter if you send this data over the internet to some third-party providers, because it's not sensitive. It's just meaningless text on its own. But for some cases, it's very important. So also I would focus on that. So yeah, the smaller LLMs, they lack the advanced reasoning capabilities, then are very narrow for specific use cases, then don't have the broader knowledge, and uh, and struggle with open-ended tasks, right? So if you train the model for summarization, it's good for summarization, but if you ask it for some general knowledge question, it won't be answered because it's the model is not trained for that. So, for example,
Yeah, yeah,
chatbots,
yeah.
actually, small LLMs may not be good for that, because users can ask about anything. They can ask about the weather, they can make small talk. So maybe for this case, smaller LLMs not so good.
So maybe to summarize this point a bit, I like them all, but it is a trade-off between performance and size, and potentially using the SLM, which can be great for privacy reasons and energy and cost reasons, might require more initial technical setup,
Bigger upfront
depending on what
cost.
you exactly want to do.
Yeah.
Then let's, I would say, move to the. We're already approaching half-hour mark, so we can move to the future of SLMs. What do we think are, and what can we already see as emerging trends, and how do we see this developing further? And I can probably briefly start on this by saying that the hybrid approaches, where you combine, and we've touched upon this in the conversation previously, where you combine SLMs with retrieval systems, is an exciting use case. So we've also touched upon it in earlier episodes, but retrieval augmented generation, which is obviously relevant for LLMs as well, or any sort of retrieval systems that add knowledge that's task specific, like internal knowledge database information from a company, to a prompt or to a specific LLM prompt where I want the answer to a question. That is an exciting one. That's going to become probably more important. Then also the combination of multiple small models to solve certain tasks, where you have specialists in different fields and combine them in the right way. A big one, probably where a lot more can be achieved. The other buzzword that you often hear in this field, but it is an important one, is AI democratization, where right now the large language models, at least training foundational models, requires massive capital, massive infrastructure, and only either very well funded startups like Mistral in France or Aleph Alpha in Germany, or of course OpenAI, or the big players can do it. Now, for more and more use cases where SLMs become important, training them yourself suddenly doesn't require a lot of capex anymore. So AI democratization, foundation models, smaller ones, becoming available from loads more different players on the market is for sure an exciting one and a very positive development that we see in the field. Alex, if you want to add to this point, what do you think about the further trends
Okay,
when
so
touching upon SLMs?
yeah, if we talk about trends, I think SLMs are sort of the future because this model that we are currently running is not sustainable in the long term because LLMs use a lot of power. It's like supposed to, by some estimates, 8% of US power by 2023 will be spent on just powering data centers and AI stuff, right? And a single GPT query uses about 3 watt hours. So it's a lot of power, like a single query. So in the long term, we are not able uh, to allow ourselves to burn coal and poison the atmosphere and burn down forests just so we can ask ChatGPT to write better email for you. Like it can't work. Like a lot of those companies, like actually pretty much all of them, like ChatGPT, like OpenAI, I mean, like Anthropic, Mistral, they all rely on external funding from investors. And actually, for example, Stable Diffusion, so Stability AI, right now, they are pretty much dead because they burned out all the money on the computational power, and it's actually not financially viable model, right? So if you are talking about the broad picture, like not even focusing on the advantages and disadvantages, it's not sustainable in the long term to spend so much money on so much computing power for such simple task. We'll probably have a lot smaller dedicated LLMs for different tasks, like SLM for writing emails, SLM for something else, and all of them will be smaller. We use less power because you don't need to route all the queries to one generalist model. You can use smaller specialist models.
And as they become more easily usable, this sort of staggered approach only use the lowest cost, lowest energy consumption option on the market for obviously the quality you need will become more accessible to everybody. And it for sure makes sense that we go into that direction. To maybe quickly recap, we're approaching the end of the episode, but we started off by defining SLMs and noticing that it's a trend that should not be missed by anyone. It's very exciting and it is going to happen. We did go a bit into the technical aspects and the different ways of arriving at SLMs from the ground up or distilling from a larger one. We talked about the obvious advantages. It uses less energy. It needs less computing power. It therefore is more affordable. Latency can be lower. If it's on device, it's a massive advantage for privacy because I don't need to trust any cloud provider or any. I basically just don't have to expose my data to any sort of malicious attacks if it stays on device. We talked about use cases from healthcare over smart homes, automotive systems, and other fields to then also cover the limitations, challenges. Obviously, it is a trade off between size and performance and ease of use versus the advantages that SLMs have because technical setup is something more challenging. And then we gave a little bit of an outlook where in the future we see staggered usage. So only use what you need to achieve your task as a big one, and also hybrid approaches where retrieval systems and SLMs work together, as well as a mixture of experts that you already see in LLMs also coming to the SLM space.
Yeah,
Alex,
and
anything to add here?
Yeah, maybe I will just leave you with one thought. Just try it out. Try out smaller LLMs. There is application called LM Studio that you can install on Mac, Windows, I think even Linux, and it makes it extremely easy to download the smaller models, run it locally, and test them yourself. So I would say test it out. Maybe it's what actually good for use case. Maybe it's not, but it's cost you very little to try it out, and maybe it will turn out that you don't need to use LLM. You can use small LLM. Who knows?
And with obvious and multiply stated upside that you can win from that. Thanks so much. Thanks everybody. Thanks Alex. Thanks to the listeners for today. I hope you enjoyed it. I could take something useful from it. And see you in the next one. Thanks everybody.
Thank you. See you.
Thank you for listening to AI Basecamp podcast. If you need help implementing AI solutions, go to K2AI and book a free consultation today.